Hopefully you now know a little more about how VLANs can be used, and you might even have some idea of how you would form your own VLANs. Now we'll look at the options you have to create VLANs. Before we start, I should take a minute to review something about switching that we discussed in an earlier lesson. Remember how we learned that the term switch is actually a marketing term that has no standards associated with it? This means that though some switches can repeat, bridge, and route, not all manufacturers' switches have the same capabilities. So this means that some switches do not support creating VLANs. Furthermore, not all switches that do support VLANs have the same capabilities. So, for the purpose of our discussion, the VLAN capabilities we are exploring here are those found only in top-level switches. Let's start building our VLAN. The first and most basic way to create a VLAN is based on switch ports. If a port is assigned to a specific VLAN, any station connecting to that port automatically joins the VLAN. The next way to organize a VLAN is based on the MAC address. Once again, this is a very basic way to create a VLAN and allows a network manager to group users based only on the MAC addresses of the stations. The next possible VLAN criteria is protocol type. VLANs can group devices based on what protocol the devices are running. These protocols can be IP, IPX, AppleTalk, SNA, and hundreds more. Basing VLAN policies on protocols is considered a very powerful method of creating VLANs. Another way to organize VLANs is based upon the network layer address. Wait a minute. Isn't that what a router does? Well, while routers do separate networks based on network layer addresses, VLANs take it a step farther. Remember, a router limits creation of networks to only its own local ports. Switches and VLANs can create a routed network using network addressing across many different switches. This next one is a little more difficult to understand, so pay close attention. Building a VLAN based on multicast addresses creates a very useful tool for controlling traffic on the network. A multicast address is an address that needs to go to multiple devices. Since bridges don't know where those devices are located, they flood packets everywhere. A VLAN groups together only some of the devices on a LAN, so when a multicast address is flooded, it's contained within the VLAN. So the VLAN reduces the amount of traffic flooded to the rest of the network. The next type of VLAN is called custom-defined, and this is the most complex of all VLAN creation methods. Remember what the MAC and network layer packets look like? There is lots of information in there, remember? Using the custom-defined method, a switch can be configured to search for a piece of information contained within the frame and use it to create a separate VLAN. Last but not least is authentication. This is probably the most important VLAN assignment method used today. Using this method, the network manager assigns all users to specific VLANs. When users connect to the network, they are prompted for a name and password to access the network. Based on their reply, they're assigned the VLAN the network manager specified. It's important to note that the authentication we're discussing here is access to the network itself, not a PC or any server on the network. A later lesson discusses authentication in more depth.